All right, and welcome back to chapter 3. On this section, 3.3, we're going to cover properties of logarithms. So what are our goals? We're going to use change of base formula to rewrite and evaluate logs. We're going to use property of logs. We're going to talk about what they are. And then we're going to use property of logs to expand or condense logarithmic expressions. And then we're going to apply that. So let's first get into change of base rule. Actually, I actually used this rule in the last video to graph a function that had base 2. I don't know if you remember that. So let me first explain to you what it is. So a lot of calculators, they only have two types of keys, one for the common log, which is base 10, and the other one for a natural log, which is base e. So they either have ln or log. Those are the most commonly used logarithms, the base 10 and the base e, but sometimes we need to evaluate logarithms with other bases. So how do we do this? So in order to do this, we do something that's called change of base. So let's say here, suppose you have numbers a, b, and x that are positive, where a and b are not 1. So then you can convert log a of x to a different base in this way. You can do it one of three ways. You can either rewrite it as log of x over log of a with the same base b. You can also rewrite it as log of x over log of a with base 10, which is something you can enter in the calculator. Or you can rewrite them both as natural log, which is basically the same case as base b, but instead it's specific e, right? Where b is e, haha. So ln of x over ln of a is the same thing as saying log base a of x. So let's look at an example. So suppose you wanted to calculate log base 4 of 25. So you would rewrite this in your calculator log of 25 over log of 4. So make sure that you have enough parentheses so the calculator knows you're finding the log of 25 over the log of 4. Okay, so that's basically how you would do it. Okay, so then let's talk about some properties of logs. Okay, so remember that logarithmic function is an inverse of the exponential function, yeah? And then you remember properties of exponents. We went over this in college math. And basically, there's a set of properties of exponents where you have, when you multiply exponents of the same base, you add the exponents, and when you have a quotient where you have one base over another and you have different exponents, you subtract. So those properties of exponents, they have corresponding properties with logs, because remember that the logarithm is basically the exponent of the exponential function. So let's say, for instance, you have this property where you multiply a to the power u times a to the power v will equal a to the power u plus v. The corresponding logarithmic property of this would be log base a of the product is equal to the sum of log base AU plus log base A of V. So you notice here, when you multiply, you add. So there's a couple of properties. There's product, quotient, and power. So we just went over product. And here's the same thing for natural log. It's just the same thing, except instead of writing log A, you just write ln. No difference. The quotient property. So if you're taking the log of a quotient, so log base A of u over v is the same as the difference. So log base A of u minus log base A of v. And this is the natural log. And then the power property, where you have log base A of u to the n power. So remember, we bring that to the front. And that's equal to n log base A of u. So that also applies for natural logs. So let's use it, right? Super fun example. So let's write each logarithm in terms of ln of 2 and ln of 3. So ln of 6. So how do we do that? Well, for one thing, we know that ln of 6 is equal to 2 times 3. So we would write that first. Then we'd say, okay, I'm taking the ln of a product. So since I'm multiplying two things here by product property, I can expand this and rewrite this as ln of 2 plus ln of 3, yeah? And that's it. So that's exactly it for this example. And then the next one, I'm taking the ln of 2 over 27. Since I'm taking the ln of a quotient, I can expand this logarithm as ln of 2 minus the denominator, ln of the denominator, okay? And since I need to express it in terms of ln of 2 and ln of 3, ln of 2 is fine, but now ln of 27 I can rewrite as ln of 3 cubed, okay? Because 27 is 3 cubed, yeah? So now that I have the power, I can use power property and bring it to the front, and my final answer will be ln of 2 minus 3 ln of 3. All right, so let's talk about that. Why are we learning these properties of logarithms? Well, they're useful in rewriting the expressions in terms that simplify the operations of algebras. So these properties take complicated products, quotients, and exponential forms into simpler sums, differences, and products, respectively. So let's do one here. So let's say here you have log base 4 of, and then imagine that there's parentheses over all of this here, 5x cubed y. Okay, so 5x cubed y, if you're trying to find the log of this, you can expand this using what property? They're all being multiplied. 5 is being multiplied by x cubed, and x cubed is being multiplied by y. Yes, they're all close to each other. So I can expand this into three sums, right? I can expand this into a sum of three things. So log base 4 of 5 plus log base 4 of x cubed plus log base 4 of y, so using the product property. And then am I done here? What else can I do? Also, observe that I have log base 4 of x cubed. I can simplify this, right? Using the power property, I bring it to the front. And so my final answer will be log base 4 of 5 plus 3 log base 4 of x plus plus log base 4 of y. And here, a common question would be, well, when do you know how to stop? When do you know to stop expanding and to stop applying the properties? Well, let me tell you. You stop applying the properties when you literally don't have anything you can apply it to. So like for instance, here, 5 is just 5. It's not multiplied with anything else. Okay, fine. And in this one, there's no exponents. There's nothing else inside the argument that's being multiplied. And same thing here. Okay. So let's do another example. What if I want to expand ln of the quotient square root of 3x minus 5 over 7? So first thing that we do is when we have like radicals, we're going to rewrite them using a fraction exponent. The exponent is a fraction. So we know by now that the square root of a function can be rewritten as that expression to the half power, okay? So this is actually ln of 3x minus 5 to the half power over 7. So then what would I do next? Well, the next thing that you do is the quotient property. So using this, this quotient becomes ln of 3x minus 5 to the half power minus ln of 7. And then you have this exponent, so we bring that to the front by the power property. So our final answer will be 1/2 ln of 3x minus 5 minus ln of 7. And here, I can already imagine someone saying, well, wait a minute, wait a second, Ms. Diaz, how come I can't expand 3x minus 5? So take a second and think about that. Yes, 3 is being multiplied by x, but the entire argument is not in a product form or a quotient form. There's this minus 5 in there that changes things, okay? And because there's this minus 5 in there inside the argument, and you can see because there's parentheses there, there's nothing we can do to it. We can't rewrite this. We can't use the properties. They don't apply. It has to be just the product, just being multiplied, or just a quotient. Okay, so that's it for 3.3. Your homework is 1 through 25 odd, and these other guys. And happy studying. This is something that we studied last semester, so good luck, and I will see you on the next video.